How can you make sure your embedded system's functional requirements are correct? How can you verify automatically that your system, your code, meets its functional specification without writing any single test case? Let's see Stimulus live. We'll use the example of the climate control system you probably have in your car. You can see this block diagram with the system architecture. We have here the climate control system that we want to specify, a thermal model of the car, a sensor measuring the temperature that is given in a feedback loop to the controller. We can look to the glossary to see the signals used in this system. For instance, the command has 3 possible values: heat, standby, and cool. Let's have a look at the controller requirements. I double-click on this box, and I can see 4 requirements. The 2 first ones are classic. If the temperature measured by the sensor is too low, we heat. We include an allowed deviation, otherwise, as soon as we get above or under the desired temperature, we would have to heat or to cool, getting the system changing its running mode too often as shown here. The 2 last ones are used to stop temporarily the system. For instance, if we were in the cooling mode and the temperature becomes lower than the desired temperature minus the allowed deviation, we can just put the system in standby mode, no need to heat immediately. Let's see how our control specification behaves. We will stimulate the system and we'll stimulate it using a scenario defined here. The scenario is very simple. For 90 seconds, the desired temperature is 19 degrees, and then for the same duration, it will be 22 degrees. Let's click on play. We'll make 200 executions of 200 steps automatically. We can observe in one graph the measured temperature evolution in blue and the desired temperature in green. In the other graph, we see the signal command that changes from one value to another one according to the temperature evolution. Stimulus reports some errors. This red vertical line corresponds to conflicting requirements. Which requirements are conflicting? Let's open the error message. Stimulus has found a conflict at the round 160. We can see the 2 conflicting requirements. Command shall be cool is conflicting with command shall be standby. Why? At the moment of the error, desired temperature is set to 19. The measured temperature is too high, so the command should be cool. Simultaneously, the other requirement applies also. At the previous cycle, the command was heat, and the measured temperature was too high. Thus, the command should be standby. The 2 conditions aren't mutually exclusive, so they can be true simultaneously, thus the conflict. Let's precise the conditions for the 2 first requirements by adding a period of stability of 2 seconds for the desired temperature. Here is the version 2. Let's drag and drop the V2 into the controller block and restart the simulation. Let's make directly 400 execution of our specification. This time, no error message, no conflict has surfaced. The second version of the specification has no conflict. We could run thousands and thousands of executions overnight so as to increase even more our level of confidence. Another way is to unleash the constraints in the test scenario. Here is another one where we randomize the desired temperature as well as its duration. Here is one possible test vector generated from this scenario. And another one. And another one. Or 5 in one shot. Let's drag and drop this scenario into the climate control test environment. We perform 400 executions with more diverse input data. no error message has been produced, we can be very confident that the conflicting requirements issue has been resolved. Let's see now how Stimulus automates radically the functional tests of the real code or of your embedded systems. You can see here a code that has been developed, either manual code compiled and put into a DLL, or some generated code put into an FMU. Let's replace the controller specification with the code that implements it. We create an observer. Let's rename it Controller Observer. We drag and drop the control specification, strongly validated already, into the observer. We go back to the test environment. We'll reuse our original test scenario, and we start to test the code. Let's do 100 executions of 300 steps. The observer has turned red, indicating that the specification is violated by the code. Let's open the error messages and click on one error message. We can see that the execution number 3 reveals an error. The code violates the specification at 260 seconds. And the violated requirement is the cool requirement. We can run automatically thousands of executions. Any violation of the specification by the implementation is reported. Why don't you try it?